Hey, we've written quite a bit of code that now allows multiple blockchains to interact with each other in a network, both through an API and real-time interaction through a pub/sub implementation. However, there are a couple slight oddities with the current implementation. One weird side effect is that in our publisher-subscriber class, the publisher always publishes a message to itself. Because it broadcasts a message on a channel to every subscriber to that channel, the pub/sub class currently sends messages to itself. After all, it's subscribed to the channels that it's using as a publisher too. Now, it's not a big deal because those messages shouldn't have any effect. After all, it's only sending a message of its own current state. But it is a little strange, so let's prevent the behavior. One way to approach this is to temporarily unsubscribe from a channel as soon as we want to publish it. Then as soon as we're done publishing to that channel, we'll resubscribe to that channel to make sure we can receive any new messages. This means that the first method that we'll call in the publish function will be the subscriber unsubscribe function, and not the publish function actually. We'll call this subscriber or this .subscriber .unsubscribe. And this allows us to unsubscribe from the designated channel. And the neat thing about this unsubscribe method is that we get a callback once it completes. So once we've successfully unsubscribed from the channel, well, now's the time to use the publisher to publish to that channel. And since the subscriber is unsubscribed from that channel in this local instance, it's not going to receive the result of this publish message. We can use the same pattern to have a callback at the result of the publish to now use the subscriber to resubscribe to that channel as well. So this makes a three-step process where first we unsubscribe from the channel, then we publish the message to our channel, and then we resubscribe back to that channel again. Cool. So this will make sure publishers do not send non-consequential messages to the same local subscriber. Nice. Another slightly odd and similar side effect is the synchronization code, or relating to the synchronization code. This code will make sure that a new peer synchronizes with the root node in an attempt to get the longest chain. However, this also runs for the root node itself. So the root node is going to send a request to its own address to synchronize, which is a redundant action. So let's add a condition that this request should only run if the selected port is not the default port. So in the final callback, we'll add an if condition. And if port is not equal to the default port, that is when we want to sync the chain. Otherwise, if the port is the default port, we're not going to call the sync chains code. Nice. Now, as you save this, make sure you have all the changes, both here in the index.js file, as well as the pub/sub file, and then fire up the main application in the command line. So npm run dev. And this time we're listening at localhost 3000, and we have some nice clean output. Cool, so this clean output means that the request to synchronize with itself did not happen for the root blockchain application. But we still want to make sure that the synchronization occurs for other nodes, so open up a second command line and then fire up a dev peer. And as we do so, it says replace chain on a sync. Cool, so it's getting that root node from the root address, and this says the incoming chain must be longer. Now, one thing you'll also have noticed is that the root node is getting a request, and that is probably because you still might have this experimentation code, which is broadcasting the chain after a 1000 millisecond delay. So if you save this, it'll refire, and if you fire the dev peer, once more you're going to see that it's going to try to replace a chain on a sync. The incoming chain must be longer, but no longer are we getting that extra message received that a blockchain was broadcasted. Cool. The last thing to check is that we're making sure that it doesn't publish to itself when it publishes a message. So a way we can do that is by sending a post request to mine a block at the root node. Go ahead and open up Postman. We're going to want to configure an API/mine request. Again, hopefully you have this saved. You're going to want to select body and then raw application JSON. And then we have our foo data. Make sure everything is surrounded by double quotes and go ahead and click send. So this will fire a block for the original root node. And as we do so, notice that the root node's output remains clean. It doesn't publish to itself, but it does publish to the second instance. So the message is received and it's getting that foo data in the second peer that we actually sent to the root node. So broadcasting is still working and synchronization is still working as well. Awesome. So that takes care of the redundant behavior we had as we were extending this blockchain to interact with multiple nodes. That's great. We've now taken care of the core blockchain as well as multiple blockchains interacting through an API and a network. That's a lot of great work. Now it's time for a big shift. We're going to start focusing on the actual cryptocurrency portion of the project. We're going to add wallet and transaction objects to the application. And we're going to return to the reliable approach of test-driven development for this core logic. Really exciting stuff, and see you in the next section.